Hello, hello. Are we live? Welcome back to the Advent of Syntran. Today is day 19. Let's get into it. Let's make a new directory and download the input. And let's take a look at the puzzle. As usual for the last couple days, I have looked at this ahead of time. So let's save the test input. And I should be able to echo that. Right. I keep forgetting this step. I have everything else automated. I think I need to like source the bash file instead of just running it, or maybe I need to exec it. I think that's what I can do that will keep me in the directory. Why did this, Callie? No jumping on the desk, please. Why did this not echo anything? Did I save the wrong file? What? Did I not save this? Could have sworn I saved that. Okay, so there's the test input echoed. So what we have today is we basically have to interpret a program. Callie can't be on the desk. One more warning. Callie hates it when I stream. What key did I even press? Or what key did Callie press? So we have a program and some data. Basically every program, they call it a workflow. It's really a program. So this is a function. You have the function EX, and inside these curly braces is the definition of the function. So if x is greater than 10, we're going to call the 1 function. Else, if m is 20, we're going to call the 2 function. Else, if a is greater than 30, we're going to reject the what the hell is in this puzzle? The part. So we're going to accept or reject each part. And if none of these conditions are true, then the final else is we're just going to accept it for the function EX. So we have various lines of functions. There's a function PX and a function PV. And all of these functions will call other functions in most cases, like PX will call QKQ. These have terrible names that are really hard to pronounce. So those are all the functions in the program, and then we have some data in the program. So every line of data is like a struct with an X member, an M member, and an A member, and an S member. Do you get it? The structs spell Xmas. So allegedly they stand for something, but it's just Xmas. Come on. It doesn't really matter that it's a struct. I think I'm going to treat these as arrays, and then we need to parse this program and basically interpret the program. It's really puzzles like this. I think today looks pretty fun. It might take me a while, but I think it looks fun. It's really puzzles like this that inspired me to make an interpreter, because there are multiple ways to solve this, but the way that they want you to solve it is to basically write your own interpreter for whatever language this is. It's just a made-up language, I assume. So last year, I forget which day it was, but there was a puzzle where you had to parse like a mathematical expression tree and then evaluate it. And now we get to interpret this kind of program with if and else, and like in 2019, there were these int code problems. So if you can solve puzzles like these, you honestly have the skills to make your own interpreter. And it's things like this that inspired me to make syntran. All right, yeah, let's take a look at the real input. So I think every Xmas starts with an X. Is there anything that starts with not an X? These are regular expressions, by the way, that I'm searching for down here. This caret means beginning of the line, caret bracket, caret brace bracket, caret X means anything that's not an X. So if I search for anything that's not a Y, every one of these lines matches. But if I search for lines that don't have X as the first member of the struct, I don't find anything. So it's always X, and then we have some digits. I don't really care about them, but I don't want to be greedy, so I do need to match the digits. And then a comma, and then do we have anything that's not an M? So first of all, there are M's. So it's always M second. And then I just have to keep going with this regular expression. I just want to test that I have that syntax right. So you have M equals more digits, any number of times, and then another comma, and then it's always A, right? So do we have anything that's not an A? Nope. Yeah, so these structs are always in the same order. And that means I can just treat this as an array with X at 0 and M at 1 and A at 2 and S at 3. And that makes things easier because I have arrays in my language, but I don't have structs. And then every time I interpret a program, I just have to map this character to one of my array indices, but that should make things easier. So uppercase A means accept, uppercase R means reject, and anything else is a function call. So like xv here, that means if we satisfy this condition in the if else chain, then we're going to call the function xv. So the first thing I need to do is just index all of these identifiers in an array. Basically, that's going to be the first thing in the line. And then yeah, I need to map all of these strings to an element in some other array so that I can just look these up in a table instead of scanning a bunch of strings. If you remember, we did this in the ghost map or the ghost maze problem day. Hey, Vision for All, welcome to the stream. What day was the ghost maze? I think it was, oh, it was day 8. Yeah, so in day 8, we had all these identifiers, and I stored them in an array, and then mapped all of the identifiers to integer indices into the array. So I'm going to do like the same thing here that we did on day 8. I might even copy and paste some of my code. I don't know. And I'm also going to have to count the number of functions. They call these workflows, but I'm probably going to call them functions because that's how I think of them. Golly. Hashcat keeps bumping into my microphone, but there are no hashes today. Sorry, Callie. Okay. Yeah, so I need to count lines. I think I'll make 2 passes. One pass to count all of the functions and all of these are function lines, and then all of the data lines after they're delimited by a blank line, but they also have a special format where all of these start with a brace and all of these start with like an alphanumeric character. Maybe it's all alphabetical. So those should be easy to count. So the number of functions is going to be 0, and n, what do I want to call this, variables or data. I don't know, data, DA for data, only 3 letters so that the number of characters is the same as this variable. And do all of the functions start with letters? Maybe I want to open this up in a different pane. So we have lines that start with A through Z, or are they always lowercase? Do I have any lines that don't start with those things? Yes, and it's only the data lines. So, yeah, I can just check if the first letter is A through Z, and then that's it for the function lines. Now that I have this ASCII converter, I can implement a very efficient isAlpha function. So I want to put that in my utilities. We have an isDigit function, but this could be optimized. So we have an isDigit function, and I'm going to have an isAlpha function. I don't really care if it's uppercase or lowercase. I think there are no uppercase characters in this input, so I can treat them all the same. And this is going to be, the nice thing about the ASCII sequence is that things are alphabetically in order. So if this character is alphabetic, it's going to be in a certain range. Yeah, this function can be a one-liner. So it's going to be A is less than the value of the current character, or less than or equal, right? Because it could be A. And less than Z, or less than or equal to Z. So that's one case, or we could have uppercase characters. So this could be uppercase A, or this could be uppercase Z. So I think that's it for that function. And now instead of like scanning 26 or 52 different characters, which is what this function does, this just makes 4 comparisons. So this should be faster. I guess I can't really be sure about that without a benchmark, but you know, currently my isDigit function, it scans this entire string, and that could potentially take a while for like 52 alphabetic characters. So I think it's more optimal to do it with comparisons like this than scanning a string. So, yeah, I think I have to check for the empty line first. So if the string is an empty line, then I'm not going to do anything. Or if it's not the empty string, then I am going to do something. Okay, because if I try to like check the first character, but I have an empty line, that's going to be an array, out of bounds array index. Hey, Sweezy man, what's Gucci? Welcome to the chat, or welcome to the stream. Everything is Gucci. At least everything is Gucci for now. It might take a turn towards the south later. Who knows? So if the current character is alphabetic, or the first character really, then we're going to increment the functions, the number of functions, Otherwise, which year day am I working on? 2023, day 19. So the very latest puzzle. I don't work on them at midnight because I'm in the East Coast time zone, and I would rather sleep than work on one of these for like a couple hours at midnight. But I do usually work on them same day. So this is the latest day. If it's some other line, then we're going to increment the data. So that should count everything. Or not. Right, this binds. The not operator binds to the string before the double equals operator. So I need parentheses. Okay, so we have 11 functions and 5 pieces of data. That sounds right. We have 11 functions and 5 pieces of data. Yep. Now we're going to make a second pass to save something. I'm not sure what format I want to save these in. So I reset these to 0 because I need to use those as indices. And then we're going to have the same thing here, except we're going to actually save some stuff. I think I'm going to save the data first because that's easier. And what does my data look like? Like I said, I want to treat these as an array. I'm not going to bother with like the struct attribute with x, m, a, and s. This is just going to be an array of length 4. So overall, for all of this data, I'm going to have an array of size 4 by the total number of data lines. So 4 by 5 for the example input. And I need to allocate that. This is going to be some dummy value initially, and it's going to be 4. I think I want to parameterize this. I don't know. Maybe I'll just hard code 4 all over the place. That doesn't really seem like the right thing to do. N xmas. Xmas. There we go. 4 by however many lines of data there are. So xmas, N xmas is going to be a constant. I don't really have constants in this language, but I can capitalize them as if they're a constant. So that's the data array, and then I need to parse these out of the string and then save them. So I'm going to split by brackets, or braces, I mean, and the letters x, a, m, and s, equals signs, and commas. So that should get rid of everything except the numbers using my split function. So we're going to split the string by braces, xmas, equals, and commas. I think that's right. All of these things are already declared. Okay. So we took this string and we split it into a vector of strings, but actually I want the integers inside of there, so I can use a different function for that. And that is parse i32 delim, and it takes the same arguments as split. So this is actually, let's call it D. It's just one piece of data of length 4. And then I need to pack that into an array. I think I'll do this the dirty way. So data 0 and DA is D0. This is like just on the verge of what I would use a loop for. I think 4 is kind of pushing it. I should really put this in a loop. But if it was 2, I would definitely copy the lines like this. If it was 3, I might or might not. 4 is kind of pushing it, but I'm lazy. And let's see if that saved everything. I want to print these higher up. Print KN. That's wrong. That doesn't exist anymore. Okay, so there's all the data packed into a rank 2 array. So you have 787, 2655, and then the last couple are 2188 and 1013. I think those look correct. So that's the easy part. Now I have to figure out what I want to do with the functions. I might just leave them as strings initially. And then sort of interpret them on the fly every time I call them. I do want to at least build a table of the identifiers so I can look those up efficiently. But at first, I think I might just save these as one string per line, or one string per function. So it's an empty string initially, and this is just a vector of strings. And that's the size. I might change this later, but this is how I'm gonna start. Okay, so there are all of the functions in one single line, but they are comma separated, so that is a vector of strings. Now, maybe I also want to parse out the function identifiers from this. So if I split by a left brace, then I'll get the function identifier as one of the outputs from the split function. Split by a left brace. And then the function ID is going to be the first thing in this vector of strings. Function identifiers. You could call these the function names or the function labels. I think I'll call them function IDs. They're actually strings, they're not integers. I think I'm gonna get this mixed up with an integer though. So I'm gonna call these function labels. I want this to be another array. Okay, so those are all the function labels. Is this, yeah, this is the test input. So we have px, then pv, then lnx, and finally hdj. I think those are right. Now, I think I want to make an, yeah, do I want to like compile these ahead of time? Yeah, so here's the thing with the input. Any one of these functions could get called many times. Well, here px really only gets called in one place. But if we look at xr, whole word xr, okay, it only gets called in one place. But you never know. There might be like loops in this function call graph. So you could have each function getting called many times. And in that case, it might be good to optimize the calling by like compiling whatever you can instead of like reparsing the same data out of a string every time you call the same function. First of all, how big is this input? A lot to scroll through. Where's the data that I'm looking for? I don't want to reprint these strings every time. So we have 600 functions and 200 pieces of data. I don't know, maybe you could interpret it on the fly and parse the same thing out of a string every time you call a function, but it doesn't seem like the right way to do it. And I don't know what's coming in part 2, so I think I should probably do this the right way. So what do I want to parse out of here? I don't think I'm going to bother parsing the XMAS because that's a very quick scan. You only have to scan through 4 things to figure out which one of the data array indices that is trying to compare something to. I probably want to parse the integer and which function gets called. So let's call this like the body of a function. We can get that out of the split operation, and we can do the same split that's splitting off the braces, actually. So we're going to call that the body string initially. And I want to split by both braces. Do I want bodies, plural? Yeah, I think I want to get, I have to get all of my function labels first, and then I can compile the function bodies. So this is strings 1. Okay, where are the bodies? Did I save that? Oh, here they are. So the first function body is just this. The curly braces have been stripped out. So is that right? Yeah, I think that seems right. And then the second function body is this. Okay. Now I want to sort of compile these function bodies. I know I do a lot of printing, but this is how I debug things. So I'm paranoid and I print things at every step. So, okay, there's the first one. I might want another blank line just to delimit this stuff. And maybe I actually don't care about this right now. Where this is the real input. Okay, so we have px, and this is the body of px. So px, and then this is the body of px. Now what I want to do is I want to split this by commas. So the comma delimits everything in the chain of if, else, if, else, if, else. So like what this function body means is if a is less than 2006, call this function. Else, if m is greater than 2090, do this thing, where a isn't a function, it's just the special except endpoint. And if none of those things are true, finally, else, call function rfg. So I want to split this by commas, and then that will give me each if, else clause. Sorry, my desktop audio is really loud. Let me turn that down. So the clauses are going to be the body split by commas. These are if, else, if, else clauses. The first one is going to be the if clause, and the last one is going to be the else clause, and then everything in the middle is going to be an else if clause. There are multiple ways to solve this today. I was thinking one way that might be kind of easier is to translate this into another language, like translate this into C or translate it into Python. And by that I mean translate these functions into a Python program and then just run that in Python. I mean that would be like equally fun as the way I'm doing it, but I'm trying to like interpret this program myself. But if you were trying to solve this by like translating the program into Python, then you would do this with if and else if clauses. Did I print that? I never actually printed that. Okay, yeah, so some of these only have like 2 clauses. So it's really just if and else. There is no else if. Some of them have 3 or more. I wonder what the max number of clauses is. Yeah, I think I do need to know that, because I might put these into an array, and then I need to know the size that that array needs to be. And I don't want to do like more passes again, because I'm already doing multiple passes. So we only have 3 for the test input. Wow, that takes a second. Okay, for the real input, it's only 4. That's really not a lot of clauses. I thought we would have more complicated programs. Like, here's one for example. This is a function body with 4 clauses. You have 1 if, 2 else ifs, and then finally an else. And that's apparently the biggest one that there is. Now that I know that, I don't want to bother calculating it actually, because I don't want to do this in multiple passes. I'm just gonna have this hard coded at some conservative upper limit. This is a capacity, really. So going to be n clauses cap by the number of functions. And this capacity, you could actually do it at 4 for my input, but I don't know how similar everybody else's input is to mine, so I'm going to make it 8 just to be safe. And yeah, what type do I want this to be? I think I might actually want parallel arrays. Because we're going to have like the Xmas index for everything, then we're going to have the number to compare it to, and then we're going to have the function that we call if that clause or if that conditional is true. So there's going to be, I think, 3 parallel arrays. There's going to be the Xmas index, the number to compare it to, and then the function to call. And the nice thing is that X, M, A, and S are all 1 letter. So we have this character, and then the operator is always the second character. So I don't have to do any parsing to do that. I can just look at character at position 0 or position 1 to get the second character. I do need to have special cases for A and R because these are like accept and reject returns. If we get one of these, we can return immediately. If we have to call a function though, then we have to call some other function. So this is the real input. So I don't actually want function clauses. I want the things that are within each clause. So those things are going to be like the Xmas ID or the Xmas index and the number to compare it to. And finally, the function to call. These are all going to be rank 2 arrays because we have one dimension for the function and another dimension for the clause. These are all going to be integers, so I'm just going to set them to -3 to start out, actually. I'll explain that in a second. So the size is n clauses cap by n function. -3 is because we have these special accept and reject things, because every function call is going to be an index into another function. So those are going to be 0 through nfn -1. But I have special cases for accept and reject, so I'm going to make those -1 and -2. And then if I get like -3, that's going to be out of bounds. So that's why I want to initialize all of these to -3. That only really matters for the function call. For the other things, it's less important. I also need to know the number of clauses for each function. Why not -3? This is just my default dummy value. This doesn't exist anymore. So that is going to be the size of clauses. It's a vector, so there's only a 0 size. It's the same as this expression. Okay, so we have all functions with either 2 or 3 clauses for the test input. That makes sense. For the real input, some of them have 4. Now, how do I want to split this? I already split this by commas. Now I want to split by comparison operations and colons. First of all, what comparison operations do we have? Do we ever have like greater than or equals, or like double equals or not equals or anything like that? So we have alphanumeric stuff. And then we have a curly brace, and then we have more alphanumeric stuff. It's actually Xmas. And then what is after that? Do we ever have less than or equals? No. Do we ever have greater than or equals? No. Do we ever have equals? Well, this doesn't really count. So I want a positive number of those things. Do we ever have like not equals? Does the puzzle prompt explain this? It probably does. So what they're explaining here is an if, else chain. Because the last thing always executes if it's reached. That's how else works. If none of the other conditions apply, then the last thing always happens. That's how else works. It's always less than or more than. There's never like less than or equals. Okay, so what am I doing? I'm splitting by less than or greater than and colons. And the final clause is always just a function without any conditions. So now I need to compile each clause. So that's clauses J. This is the current clause. And I want to split that by less than or greater than or colon. So the first thing is going to be like the Xmas thing. The second one is going to be the number to compare it to. Yeah, so the first one is going to be the Xmas index. The second thing is going to be the number to compare it to. And the third thing is going to be the function call. If it's not the else clause. If it's the else clause, all we have is a function call. Didn't I already split these? No, I didn't. So we're actually going to have a special case at the last one. So I think I want to go up to -1 and then handle the else clause outside of here. Sorry, it is sweltering. I have my work computer running some huge job, and my heat is on too. So the office is like the hottest part of my house right now. Also, I closed the door so that Callie doesn't jump on my computer for 2 hours straight, or jump on my keyboard. So it is like at least 80 degrees in here. Because for the else clause, this split isn't going to return as many things. Right, because for the else clause, it's always just a function. Before that, we have an Xmas ID, and then a comparison operator, and then a number, and then a colon, and then a function label, or a function label. So we have to unpack these things from the split output. So the Xmas string, these are all just strings, is 0. We also need the operator, but we don't get that out of split because split removes all of the delimiters. When I call split, the second argument is the set of delimiters, so it removes all of these out of the output. But I can get that easily. So the operator is just going to be clause 1. And then I think that's it. see if I got that right. Nope. J, what's wrong with J? To look at the first error first. 124. What the hell is wrong with this? Expected a semicolon. Oh, right, the -1 has to be inside of that. I've never made that mistake before, so it took me a while to parse that error message. I thought I used strings. Not in this scope, I guess. Okay, so this is clauses. Okay, there are only 2 clauses. So M, and then greater than, and then 838, and then A. Okay, I seem to have parsed that correctly. Now I need to compile this. So what is op? I also need an array of operators. This I'm just gonna leave them as strings. So xmiss idx, this is going to be j comma I equals, we have to scan this from the literal xmiss string. It's in that order because they're always in that order. Do I have these indices right? So it should be n clauses and then n functions. You have n clauses and then n functions. Yep, that's right. Then the ops at the same pair of indices is just going to be the operator. Comp num equals parse I32 out of comp. Let me call this comp str. Okay, so now this takes a string and converts it or parses an integer. So then we get an integer out of that. And then finally, what is this last variable name? fn call. This is going to be the tricky part. We have to look this up in the array of function labels. So we're going to initialize it to 0. We have to scan for that in the array, which is called fn labels. So while fn labels fn call ji not equals call not. I don't have a string not equals operator, so I have to do equals and then negate it like that, unfortunately. This is going to be like the easiest thing to add to the language, but I just don't know if it probably would be worth my time because I've done this so many times and explained it on the stream so many times that it would have been faster if I just made the bang equals work for strings the same way it works for integers in this language. I don't know, should I finally bite the bullet and do that now? I don't know. I think I have to get on with today because this might take a while to do just part 1. Yeah, so while we haven't found it, we're going to increment it. I think that should do it. I want to verify the function calls first because that's the hardest part, actually. And something overflowed. Oh, right, the A and R special cases. So, yeah, before I get to those special cases, I need another drink. So I will be, whoa, I will be right back. Okay, I'm back. So accept and reject are special cases. So if call equals accept, else if call equals reject, and then this is like the default case. So accept is going to be -1, but I'm going to parameterize these. Ideally, I would make accept 0 and reject some negative number, but for the default case, I want to index into an array with this identifier. So if I used 0, that would also work as an index, and it would like clash with all of my other functions. So I want accept to be, I want accept and reject to both be negative values. So function call ji equals accept. And then this is reject. I think that's it. I hope that should fix whatever made this crash. All right, there we go. So we have a bunch of -3s. Those are dummy values past the end of the array. So you can just ignore those. But for this case, we have a function called QKQ. If I look for that, it is at line number 6. That would really be index number 5. So we have a 5 there. And then accept is -1, so that's -1. Then if I look here, we have a reject. Reject is -2. Then we have another accept, so -1. Then finally we have GD, and GD is 9. And then reject is -2. So I think these look correct. And finally we have an accept, so that's just -1. Yeah, that's basically how I wanted to compile the function calls. So the function calls, and what else did I get? The xmas indices, and the operators, and the comp nums. So let me yank those and put them right there, not like that. I don't know how to paste like this. When I paste a column, I would like to like insert new lines and not just mangle the lines that were right below me. Okay, so the Xmas IDs, basically 0 would be X, 1 would be M, 2 would be A, and 3 would be S. So 2 is A, that's right. Then 1 is M, that's right. Finally, we have 1, so that's another M. I think those look correct. Then all of the operators, these are just strings. So we have less than, greater than, there's a greater than there, which is that one. And then finally, we have this greater than, which is right there. And then the numbers to compare to. Again, we have a bunch of -3s padding the array. You can just ignore those. 2006, 2006, 2090, finally 838. Okay, I think I compiled everything. Now I have to interpret it. Or I've parsed the input and represented it as some type of syntax tree. Except it's not really a tree, it's just a bunch of parallel arrays. But now that I have that internal representation, I need to interpret that on the data that I'm given. So we're going to loop through every data element. Eventually I want to loop through everything, but let's see if I can just get the first one. I want to unpack this from my data array. I think it's just named data. I think I have to do my dirty code again. So like this, but in reverse. Oh. Yeah, I can kind of do it on one line though. Something wasn't good there. Oh, right, this is ID. Okay, so this is the first piece of data. That looks correct. How do I have, I had like a tmux selection over top of a neovim selection. That looked funny. Okay, so can I interpret this through all the function calls? So first we're going to start at in. Do I want to look that up ahead of time? I think I do want to look that up ahead of time. Oh, I forgot to handle my else clause. I have to look up the else function call the same way that I looked up everything else. But unlike everything else, the else clause doesn't have an Xmas ID or an operator or a number to compare to because it just executes unconditionally whenever it's reached. Clauses are this. So if I look at the last element of the clauses array, that's the else function call. the end of the clauses array. And then function call, instead of j, it's going to be n clauses I minus 1. And I just want to set j equals to that. There we go. So then I don't have to change all of these lines. I don't really need so many curly braces here, but whatever. Maybe if this works, I might go back and clean this up. But for now, I'm not going to touch it. So if we look at my function calls, we had -1. Yeah, and then we never had anything for PV. We have a -3 where PV should be. So if I do this again now, so we have a -1 for A, and then PV is 1, right? So PX is 0, PV is 1. So that's correct now. We have the else clause handled. Okay. Now I think we can start to interpret this, or start to evaluate this, really. We had like a parsing stage, and now we have an evaluation stage. And this is the same way the syntran interpreter works. There's a parsing stage, and then an evaluation stage. I don't know what to call these lines of data. I could call them structs, but like I don't have a struct. I'm just using an array. I also want to look up the in function identifier, because that's where everything starts. It doesn't necessarily start at the first function call. It starts at the in function call, which is down here at line 8, totally arbitrarily. So I want to look up that index. And that's going to scan just like this. Doesn't have any indices, it's just the in call. And it's just labeled in. So the in call is 7, it's line 8, so that's index 7, that's correct. Okay, so that's where we start. In call. Now we're going to keep iterating until we either accept or reject. Well, let's call that a return. So we're going to loop while not returned. I don't have an explicit return in syntran, so I always have to do it as a while loop with this exit condition. So function starts out as in, and then we're going to iterate through the clauses. So we're going to have another loop that iterates through the conditions of the if, else clauses. And we're going to iterate until one of those conditions is true. Or returned. If we hit a return in the form of either accept or reject, that's also going to break us out early. So while not returned and not condition, now we have to check the condition. There are really only two possibilities. There's less than or there's greater than. Those are the two conditions. Do I want to unpack these things? Yeah, I guess so. Maybe I just want I and j. I is going to be the function index because that's how all this code works. I just used I and j. So I is iterating through the functions and j is iterating through the clauses, and then my operator is just ops ji. So icond is just j. And then function underscore is just I. Is it comp num? I couldn't remember if it was comp num or num comp. So this is also j comma I. Which direction am I searching? I love to have things lined up, so got to get my equal signs lined up like that. Okay, now I can evaluate the comparison operation. So if op equals less than, we're going to do one thing. And there's really only one other option, which is op equals greater than. So in this case, condition is going to be, is it xmas less than the number? I think it's in that order because these operations are not transitive. Is that the math word that I'm looking for? I can't remember. Yeah, so it's always xmas on the left of the operator and then the number on the right. So it's It's not this, but it's num. So xmiss is really the index into the data. So it's d xmiss. So that's the one, and the other one is just greater than instead of less than. So that should tell us which clause is true. At the end of this, we're going to increment j. And then I think I need to decrement j to go back by 1. So we want one more condition here, which is and j is less than n clauses I. Right, and then when condition is true, we're going to increment j one more time and then break out of this while loop. So then to correct for this final incrementation, we have to decrement it right here. And then we know what the next function call is. So at this point, I equals function call ji. Is that the name of this array? Yeah, I think so. No, there are actually two special cases. Special cases, which I need to check up here, are if the function call is accept or reject. If I equals accept, and then this whole body is just the default case. Man, I hope this code is right. Like, look at how much code I have to write before I can even test something. This is like, I don't know, 246, 209. This is like 40 lines of code that is like totally untested right now. So if any of these things happen, then we can return. I don't think my returned clause is doing anything in here because I can never update the returned clause inside of this. I could actually do it in either one of these cases, actually. But in the case of acceptance, then I want to increment the actual answer that they're asking for. So if it's accepted, then what are we adding up? We're adding up the x value. And we're adding up all of the values. Right? So we add up the x, m, a, and s rating for every accepted part. that might be it. This probably isn't going to parse, and even if it does, it's probably not correct. But let's see what happens. Yep, that crashes. All right, now we have to debug. At least my code parsed. Like I didn't get a parse time error. It started to run and then it crashed. Okay, so we're getting -2, which is actually reject. So I think I'm getting a reject value and then I'm trying to call a function instead of just rejecting. So I did print this. So what happened here? We tried to evaluate 7 and then we just crashed immediately. And this stack trace is not helpful. This is actually a line number in the syntran interpreter. It's not a line in my source code right now. I mean, all of it's my source code, but this isn't the line number in the source file that I care about. So we got a function index. And then how many clauses do we get through before we crash? This should go to QQZ. I don't know how we got to reject. Clause 0 and then clause 1. Where did this go? Got the clause index. We have the function index, that's positive. We have the clause index, which is 1. So where did a -2 come from in an integer array? Oh, I have variable shadowing, do I? No, let me print these things. Oh, I got to the else clause, and then I tried to look up an operator, but there is no operator for the else clause. So I think once again, I need a special case for the else clause. So I only want to loop this up to n clauses -1. And then that right? Huh. 7540 is It's the first thing accepted. Okay, the first thing is accepted, so we add that up. And then I'm only doing the first line of data so far. So let's try the rest of the lines of data by changing this for loop. And this should go through all the lines of data now. Wow, that ran 19,114. Wow. This might be correct. Let's try it on the real data. Oh, I was worried I had an infinite loop for a second, but it was just parsing. Wonder if I could have an integer overflow problem. I think these numbers are not that big, and we only have like hundreds of them, not tens of thousands or anything crazy. So I've got a good feeling about this since this worked on the test input. Oh, right, that's part one. That wasn't... It took a while. It was honestly more like a lot of tedious work. There was nothing particularly difficult there, in my opinion. I mean, like, I've written an interpreter before, so I'm kind of biased when I say that wasn't particularly difficult. This is like a little toy language, but if you've never, like, interpreted code before, this could be a little bit to wrap your head around. Oh, God. What? Oh, this is crazy. I don't know how I was supposed to do part one, but I have no idea how to extend that to part two, other than brute force, and brute force isn't going to work for, what is this, like quintillions? So we have thousands, millions, billions, 167 trillion. And that's for the test input. Yeah, this is crazy. This is like day 5. Now, I still haven't gotten part 2 of day 5. I mean, I could like look at somebody else's code and copy it, but where's the fun in that? It's like day 5. They gave us all of these functions, and you have to apply these functions to a set of numbers. So part 1 was manageable. You had like 4 numbers that you had to apply the series of functions to. But then in part 2, they say, actually these are ranges of numbers. You have 14 numbers starting at 79, and then you have 13 numbers starting at 55. So for the test input, that's less than 30 number. It's no big deal. But for the real input, this is like a astronomical number of numbers that you have to evaluate the functions on. And you have to do like some kind of meta-analysis to figure out what the answer is. And this is sort of the same thing for day 19. I think I might give up because I have no idea how to do this. I can do it. I appreciate your confidence in me. So we're only dealing with 1 to 4,000. I don't think I have time for this anyway. What did it take me? Like an hour? It took me an hour and a half for part 1. And I think if I could do part 2, it will probably take me another hour and a half. And I don't have the time for that tonight. But I think what you have to do is work backwards. Instead of starting with a number and like starting it in and then entering the function call chain in and then going to the next function, whether that's px or qqz. I think you have to start at the acceptance endpoints and say, well, which numbers can get me accepted? Let's look at line 1, because that's where the first acceptance is. Which numbers can get me accepted? It's anything greater than 2090 So that would be like 2091 through, are we going up to 4000? Yeah, we're considering numbers from 1 to 4000. So this could get me accepted if I make it to this point. And that's only for the M value. So this is like M in 2091 to 4000. And then to get here, you also have to satisfy this condition. So the things that would satisfy this would be A in 1 through 2005. Now, how many different Xmas structs are there that satisfy that? Well, there's no condition on X and there's no condition on S. We only have conditions on A and M, so it would be like 4,000 times 4,000 because there's no condition on X or S times how many different M values are there? Well, it's 4,000 minus 2,091 plus 1. And then how many A values are there? There are 2,005 minus 1 plus 1, if you want to do that. So there are 796 million numbers if we get to function px that could get us accepted at this point. Then you have to work backwards another step and figure out, well, how do I get to function px? In this case, it's easy. It's straight from the input. So then you have to figure out of these 796 million numbers, which conditions does everything else have to satisfy to get there? And then you have to do that not just for this acceptance endpoint, but for every acceptance endpoint in the whole input. And then you have to get the intersection of all of those sets. So like I took this product a little early. You have to look at this, and then you're going to have some other set of numbers. No, not the intersection, the union. So you're going to have this set of Xmas values to get to the first acceptance endpoint. And then for every other acceptance endpoint, you're going to have some range. And then you have to take the union of all of those ranges, I think. So yeah, that's my idea of how I would do this if I wanted to finish it. But I think I'm. Did you finish this one? It's a bit finicky to get right. Yeah, like I think this would take me at least 90 minutes to do, probably longer. This feels harder than part 1. Kudos to you on getting it done. I don't know. I feel like I don't even want to start this right now. I want to end on a high note. Like, I got part 1. That's not bad. Maybe I'll just stop here and not push my luck. I think just doing unions isn't enough. Nah, I don't know. This is too much to think about. It really does remind me of day 5. Because in day 5 you have to work with ranges of numbers. And then every one of these operations is going to split your range into at least 2 different things, maybe more than 2 different ranges. Yeah. I think I'm just going to commit my code and call it a night. Okay, so we have this helper function, and then we have all the files in this directory. Where did... Oh, I think I saved this in the wrong directory. Yeah. So that's why I had that mishap in the first 5 minutes of this stream. I had this idea of solving today's problem instead of doing it the way that I did it, of just translating the input data into another programming language. Like make a Python program with a function named px that does this, and a function named pv that does this, and then just run that Python program on this data. I don't think that would work at all for part 2. So it looks like that push worked. There it is. There's part 1. That was a decent amount of code, almost 300 lines. They really get you with the part 2 sometimes. Yes, some of them aren't so bad. Like I thought yesterday wasn't bad because I just chose the right approach for part 1. Yeah, like yesterday wasn't bad, but today's part 2. This is a total twist. I'm not looking forward to doing it if I do it at all. All right, I'm gonna call it a night. I'll catch you next time. Bye.